guys, this is Gurneet. In this particular series, we'll be looking at Python interview questions asked by major tech companies, including particularly MAANG, which can help you in interview preparation and understanding Python programming language. In this video, we'll solve top 5 Python programming question and understand its solution one by one. So let's get started. Our first question says, Amy and Brad take turns in rolling a fair six-sided die. Whoever rolls a 6 first wins the game. Amy starts by rolling first. What's the probability that Amy wins? So, this is a simulation question, and we'll solve this problem statement, simulating the process a considerable number of time and check the probability that Amy wins. So the problem statement says Amy rolls the die first. So if the result is 6, then the game is over and Amy wins, right? Otherwise, it's Brad's turn to roll and it wins the game if it's a 6. Now, if not, the turn shifts back to Amy. So we will repeat the process until someone ends the game with a 6. So here the key is to understand the logic flow. So who wins under what conditions? So who wins, which means that we want Amy to win. We want to find the probability that Amy wins. And what are the conditions here? The conditions are that if she rolls the die and it is a 6. So uh, now what happens is, let's look at the code. So it says now first step is to import numpy. So we'll import a library numpy. Then we will be defining a function who won, right? And then the attributes are die and the size of, right? The size means how many times are we repeating it, right? So a count, we have a count and b count, which is Amy's count and Brad's count. So first we'll initialize the count, initialize A count and the B count. So then we'll be using a for loop over here. So we will create an iteration, right? So if now what happens is for I in range of the size, how many times we are repeating the process. So if what happens is if first what we'll do first, it's Amy's chance, right? As per the problem statement, it says that Amy starts by rolling the die. So we'll take a variable a underscore 6 and we'll use random choice, right? So what it will do, this particular line, it is used that we roll the fair dice and it will choose a random value from 0 to 6. So the random dot choice, what it'll do, it will choose a random value from the 0 to 6. Now the condition, now it's time for the condition. So if the condition says that if a underscore 6, that means the dice has a 6 value, that means we will adding a count to our a count. So the syntax will be like a underscore count plus is equal to 1, which is also equal to a count is equal to a count plus 1. So we write it down using like this, right? Now if the above condition is not true, then we'll use the else function. So if Amy does not roll a die with the value 6, we will be using, what we'll do, it's Brad's turn, right? So we'll again take a variable b underscore 6 and again we'll take a random choice from 0 to 6. Again a condition if, that means if again the Brad, if the b underscore 6 is value is equal to, if the dice value is equal to 6, then the value, the b count plus 1. So a value will be added, a count will be added to a b count, right? Now what happens is, so a underscore 6 is the data distribution for Amy and b underscore 6 is the data distribution for Brad. So if she has a 6, her count will be plus 1. Otherwise, Brad can roll the dice. And again, we have the, if Brad has a die and it's the value is 6, then then it will be count plus 1. So now the final result. So it is saying return a underscore count and divided by a underscore count plus b underscore count, which means that the final result should be number of occasion that Amy won divided by total number of Amy and Brad won, right? So this is the probability that this particular thing returning, this is returning the probability that Amy wins, right? Now if we test out this algorithm, so this is the algorithm, right? This whole, now we will test it out, the we will want to find out the probability, right? So if I use, so it is saying np.random.seed. Now this function, what it means is that the numpy random seed is a numerical value that generates a new set, or it repeats a pseudo random numbers. So the line set.seed 123, what it says is like it is setting a random number value, right? And the main point is, it why do we use it? It is used which in like to reproduce a particular sequence. We want a particular sequence of random numbers, right? So that is the reason that we use np.random.seed, right? And then we have the die value 1 2 3 4 5 6, and we will be repeating this process until 10,000 times. So uh, when we repeat the process, then we will be calculating our probability. So we will call our function who won and the die comma size, right? And that means, and then it gave us the result 0.53. So that this the result means that Amy has an upper hand in winning this game. So she has a 53% probability of winning in 10,000 times of simulation, right? So I hope this problem statement is clear. Now coming up to a second problem statement, which says, given a positive integer number consisting only of 6 digits, 6 and 9, return the maximum number you can get by changing at most one digit. So either the 6 becomes 9 or 9 becomes a 6. So now the problem statement says that we are given a positive integer and there is only one way. Now we need to have a maximum number, right? So for that, we can only turn our sixth digit to a 9, right? So for example, if we are given a number 69969, right? So in this particular number, we need to change our sixth digit to a 9. So for that, the number will look like 9996, 9996 and 9, right? So what we can solve this problem statement using two solutions. Either we just replace one 6 to a 9 and it will give us a maximum number, or we can replace all the six digits to a 9 number, right? So coming up to a first solution, what we'll do, we'll define a function, and now what we are doing is we are returning an integer value. So now what, to replace a value first, I will convert my number to a string value, replace my 6 to 9, right? And the one meaning the dot replace 6 to our 9, the one is showing that it is just one count, the count is equal to 1, so that means that we are just doing it once, right? Now after the value has been replaced, we are again shifting it back, we are converting it back to our integer value using an int function. So it will return our an integer value, right? So if I take a number 96666 to 9, and then if I call my function, then the result will be 9, and you can see that the second digit is a 6, so it has only replaced once, so that means my output looks like 9, the second is converted to 6, the sixth digit is converted to 9, so 9 9, and again those six values, the number is same as it was here. So this says that only replace once. But if I want to replace all my six digits to 9, then the solution will look like, what I'll do first, I will define my function max underscore 69 underscore all, and then give a number value, right? Then we use a k to calculate the length of the number. So first what I've done, taken my number, converted into a string number, converted into a string value, and then calculated the length, right? So what I have done again, return the string number, replace all the sixes to 9, and in my count value, I have given the k. So the length of all the, it will calculate the length of the string, right? And then it will replace all the 6 digits to 9, right? And then once it has been replaced, I again convert it back to my integer using int function and return that integer. So if I again use the same number here, so you can see that the number, the result which is it showing is that it has replaced all the 6 digits to 9, right? So I hope this problem statement is also clear. So either you can replace it once or replace all your 6 digits to a 9 number, right? So I hope this problem statement is clear. Now coming up to our third question, which says, given a positive integer number, write up a function that returns true if a number is a perfect square, else return false. So now the follow-up says that we cannot use any built-in library function such as square root. So Python has a built-in function, which is a square root, which calculates which gives us the result whether whether the number is a perfect square or not. So we cannot use it. So what we'll do, we'll be using a binary search, right? So we have divided into two steps. First, we need to find the square root of the number. Then we have to check whether it's a perfect square number. Now we will define a function valid perfect square. Now the logic that we'll be using here is that it has divided into two pointers. We have divided our number into two pointers, left and right. So if the number is less than 2, it will return true. But if it's greater than 2, like for example, 2, if we calculate the square root of 2 twos are 2 into 2, which is 4. So for example, I have a number 16, right? Uh, uh, you can see that I have a number 16 here. I'll write down 16. So I want to calculate the square root of 16. So I will first see the leftmost value and then I'll see the rightmost value. So now first the leftmost value, the 2 square, which is 4, so which is less than 16, right? So the value will increase, right? We'll shift to another value which is 3. So 3 square, which is 9, which is again less than the original number. And then we have the rightmost value. For example, again we'll go to the next number 5. So 5 square is 25, so that is the rightmost value, which is greater than the original number. So we will shift to our fourth value. So 4 square is 16, right? So in this case we can see that it is a perfect square, so it will return our value. But for example, if I have a number 8, so we need to check whether it's a perfect square or not. So in that case, I'll see 2 square 4, so which is less than the original number. So we'll shift to our next number, which is 3. 3 square, which is 9. So now the ninth number is greater than the original number, which is 9 is greater than 8, right? So in this case, it's not a perfect square, so it will give me a false value. So again, this logic has been implemented here. So if number is greater than 2, less than 2, though it will return a true value. Now we have divided into two, left and right, right? Now if the left, so we'll be using while loop, so it can update the left and right values because we are shifting. If the left number is less than the original number, in that case it will increase, right? So while loop is used to update, we are using while loop to update the left and right values. So x is equal to left plus right minus left, which is nothing but what we are doing, we are creating two pointers and we will compare the average value of these two numbers to the original number, right? So if it will be the smaller than the number, it will increase the value. If it's bigger, then it will decrease it. Or if it's the same value, then it will, if they match, it will return the true value, right? So x is equal to left plus right minus left by 2, right? So I will calculate the square number. Now, if the square number is equal to the number, it will return true. If it's not, if it's less, if the square number is less than the original number, then the left value will increase to it will shift to the next number, right? And if the else value, else means if if the squared number value is greater than the number, that means we will shift back, which we will shift to our previous number. So we will be decreasing over here, and we will return the false because it's not a, if it cannot find the match, it will return false. So if I run this code, it will give me a true because 16 is a perfect square number. But if I write down 8, right, it will give me a false value because 8 is not a perfect square number, and it has calculated using this logic. So I hope third question is also clear. Now coming up to our fourth question, which says, given an integer n, return the number of trailing zeros in n. And the follow-up says that we have to write up a solution that works in a logarithmic time complexity. Right. Now, first we have divided it into two steps. We need to divide this question into two steps. First, we have to calculate the factorial number, like the n factorial number. Then we have to calculate the number of trailing zeros. So for the first step, what we can do, we can just use the while loop to iteratively loop over the n factorial number, right? Till the loop stops until 1, right? But for the second step, we cannot get confused. It says that number of trailing zeros, not the total number of zeros. Like for example, 8 factorial is 40, 320, right? So we have two total number of zero. Total number of zeros are here 2. But the trailing zero number of trailing zeros is just 1, because 40 320, both of the numbers just have 1 0 at the end, right? If it was 400 or 3200, in that case the number of trailing zeros must be 2, right? So we have to be very careful with the calculation. Now we can solve this problem statement using two solutions. First, using a reading a string backward, right? This can be a solution, right, which is n minus 1, right? And either using a while loop. Now, how are we going to do it? First, read a string backward. So now, coming to a solution one, first is we calculate the factorial number, then we calculate the number of trailing zeros. So first, we'll define factorial 0. Then we will be calculating using a while loop. We will be calculating r factorial, which is and if the n number n is greater than 1, we'll calculate the product of it. So if it's 5 factorial, it is 5 into 4 into 3 into 2 into 1. So it's going backwards, right? So in that case, we'll be using n minus 1. This is the reason that we're using n minus 1, right? So now that we have, this is our factorial, we have calculated our factorial. Now we will, our count is equal to 0. So now we need to calculate the total number of trailing zeros. For that we'll be using a for loop. So what happens is we use for. So for in string number product, this is the syntax, right? So what is happening is that in the first part, it is much clear that we have used the while loop and it has calculated us the factorial. Now in the second part, which is to calculate the number of trailing zeros, for we have used the string method. So what have we done? We have transformed the product into a string, right? First, like we convert our product into a string value, right? It reads the uh, so we have transformed the product into a string value, and then it will read it backwards, right? So if the number is 0, it will add up a count 1. Count is equal to 1. If there is two zeros, it will count will increase. How many zeros are there? It will increase the count. If there is no 0, it will break the loop, right? So that is the reason the break command is essential over here. So as we can see that if I is equal to 0, count will increase, else it will break, right? So if I have a factorial 0, let me just execute it. So it has four trailing zeros, right? Because our main focus is to calculate the number of trailing zeros. So that means we have 4 zeros in our 20 zeros factorial, right? In our 20 factorial, we have 4 trailing zeros. Coming up to our second solution, which is using a while loop. So again, I hope this part is clear. We will iteratively calculate the product, which means the factorial, right? Now we use the while loop to calculate our trailing number of zeros. So while product is, so calculate the number of trailing zeros. So what is happening here is, we, for the product to be evenly what have we done, we have used while loop to calculate the trailing number. So for the product to be evenly divided by 10, the last number must be 0. So if we divide any number by 10, the logic there is that the last number should be 0. That is the reason 0. So that is the reason we have divided our product using 10, right? And then if the, so why we use a while loop to constantly update the while loop while the conditional condition does not stand. So here it is calculating the zeros. So if there is a 0, it will add up to the count, right? And it will return the count. So again, if I uh, execute this code, it has given me the 4. So that means either we can use a for loop to calculate the number of trailing zeros, or we can use a while loop and it will iterate. In a while loop it will iterate, right? So we will calculate the product and then we will divide the product by 10. So that is the reason we are using a while loop, right? So I hope the fourth question is also clear. Now coming up to our last question, which says a perfect number is a positive integer that is equal to the sum of its positive divisors or factors. So a divisor of an integer x is an integer that can divide x evenly, right? So we are given an integer, we need to return if n is a perfect number, otherwise we need to return false. So we can solve this problem statement using brute force and square root number. So to find out using brute force, what we'll do, we are given, so we will first define our perfect number function. We'll give divisors a blank value and then we'll use a for loop. So what it will do is, uh, it will iterate over the entire sequence from 1 to up to the integer value. So you can see that if the number is divisible, right, if it is divisible completely, that means the divisor by the number, that means we will append the divisors. If now if the sum of the divisors is equal to the number, right, so that means it will give me a true value. If it will if it's not equal to the sum, it will return a false value. For example, if I have a 28, right, so the divisors for 28 are 1, 2, 4, 7 and 14, right? So if the sum of the divisor is equal to the number, that means 28 is a perfect number. So if I write up here 28, and if I, so that means 28 is a perfect number, right? So but we cannot use a brutal force for a very large numbers because it's not time efficient. So we'll be using a square root number. Now as you can see, the same function is over here. If the number is less than 1, then we'll return false. But we, instead of, we are calculating the square root for I in range. For the integer value, we are calculating the square root of the number and int plus 1. So from 2 to number to the number, we are to the square root of the number, we are calculating, and then we'll find out the divisors. And if then will the sum of the if return sum of the divisors is equal to number. So if I run this code, it will give me the perfect number of 6 is true, right? So we are using a for loop to calculate a square root of the number. So the logic here, basically the logic here is, for example, to find our divisor of the numbers, we don't, for example, if we have a number 100, right, so if we have to find the divisors for 100, we won't have to check from 1 to 100. Instead what we'll do, we just check out the square root of the 100, which is 10, right? So that for all other variables, we have already so all other variables have been included, right? So from 100 we calculate the square root of the number, and then if we calculate the sum of the divisors, it will be equal to, if it's equal to the number, that means it's a true value. So that is the logic over here. So this is a very easy way to if we calculate using a square root number. So I hope this is clear. This problem statement is also clear. Thanks for watching. We'll come up with more Python interview questions majorly asked in bank companies. So stay tuned and keep following for more.